Welcome back to AP Statistics. This is Dr. Kling, still not affiliated with the College Board. Today's topic is simulation. And there are basically three steps in a simulation. What I've done here is to start with actually is to copy down a set of random numbers. I copied them from a table here. Anyway, and I may have miscopied some of them, but that just makes them, they're still random. Okay, so the steps in doing a simulation are you set up the odds, or the probabilities. Then you assign random numbers to or number ranges to get those probabilities. I'll show that by example. And 3, you conduct the simulation by picking random numbers, and then finally you repeat. Okay, so let's do an example to illustrate that. I'm going to do sort of part of a March Madness bracket. If you don't know about March Madness brackets, I think you'll still be able to follow what I'm doing. But let's say, so we have the part of it where a number 3 seed starts out playing a number 14 seed, and a number 6 seed plays a number 11 seed, and then the winners play each other, and then the next one goes on to the next round. So we're going to simulate 2 rounds. Okay, so the 3 and the 14, and so there are 4 possibilities for the next round. We could have either 3 or 14 win there. We could either have a 6 or 11. And then the 4 possibilities at the end, we could either have a 3, a 6, an 11, or a 14 seed be the winning team. And so remember, our first step is to set up the probabilities. So what's the probability that a 3 beats a 14? I'm going to say that's a 90%, or maybe I'll make it 90% chance. And then the 3 could, in the second round, play a 6 or an 11. So a 6, I'm going to say a 65% chance. An 11, I'm going to say an 80% chance. I'm making this up. Okay, then we have the 6 versus the 11. So the probability that a 6 beats an 11, I'm going to put at 70%. What other possibilities are there? We could have an 11 and a 14 in the third round. 11 beats a 14. I'm going to say that's a 55% chance. Oh, and I forgot there could be the 6 and the 14 could meet in the second round, so that would be 6 beats a 14. Oh, and let's go with a 75% chance for that. So I make up these probabilities, and now the next step is to assign random number ranges to those probabilities. Now I can't use 1-digit random numbers. I have to use combinations of 2 digits. And so what I'll say for I'll take combinations of 2 digits, so they can range from anywhere from 00 to 99 if I take them 2 at a time. So let's treat 00 as 100. We don't have to. We can choose any range we want. But we'll take 01 through 90 would be a win for the favorite team 3 in a game of 3 versus 14. So let's say that the low numbers 0, 1 through whatever number is the odds, like 0.90. So that's the favorite wins. And then 91 through 99 would be an upset. So that would be this one. And then for the 3 versus 6, we would do 0, 1 through 65 would be the favorite wins. And 66, wait a minute, before this one should have been 91 through 99 and 0, 0. And this would be 66 through 99 and 0, 0 would be an upset. Okay, so this is 91 through 99 and 0, 0. Okay, so that's how we'll conduct all of these. I'll just do one more. If these guys happen to play, then 0, 1 through 55 would be the favorite wins. That is team number 11, the 11th seed, and 56 through 99 or 0, 0 would be the upset, and that would be team 14 beating team 11. So that's how I will simulate this, and now we just have to pick some numbers and see what happens. So let's set up a bracket. We have 3, 14, 6, and 11. Again, this is just part of a bracket. Now let's see who wins in our first game in the first simulation. So we'll draw 2 numbers. We'll take the first 2 numbers. We get a 61. That falls within the range where the favorite wins, right? Because it falls within the 0, 1 to 90. So we say the favorite wins in that one. And now let's go to the next one. 6 versus 11. We're looking at a 0.70 range for the 6 versus 11. So let's see if we get within 1 to 70. The next one we get a 42. That's our next set. So we'll just draw lines there. Draw lines. So we have a 42, and so we also don't get an upset there. And so the 6th seed wins. And now we go to the next round, and we'll see who won there. And we get so we've used the 61, we've used the 42, we get another 42. That won't be an upset, and so we will have the favored team move to the next round. Okay, but then what's our next step? It's repeat. So we'll do this simulation another time just to see if we get a different result. 14, 6, 11, and okay, so let's draw another set of random numbers. We get 40. That's not an upset. So we get team 3. 6 versus 11. 19. Not an upset. And so we put team number 6 in there, and now we have 3 versus 6, and 3 versus 6, what do we need to not have an upset? 65. 65, and you'll see that the next 2 numbers are an 86, which is outside the range for the favorite winning, so we call it an upset, and team 6 wins. And then you could just repeat and repeat and repeat. It's a way of taking a very complex process and figuring out what the probabilities of the final outcome are, because we're interested in some senses sort of what will be the distribution of the final of the teams that make it to this round. How often will the 3 make it? How often will the 6? How often will the 11? How often will the 14? And we could do a whole bunch of these simulations, and maybe we get a result like 80, 15, 4, 1, something like that. So that it's a way of simulating a complex process. And I actually used to oversee doing that for a living. We were trying to estimate the probabilities of mortgage defaults, and what we would do is we'd simulate different paths for house prices, because when house prices went up there would be very few defaults. When house prices went down there would be a lot of defaults, and it sort of depended on how many years had elapsed before the big house price increases or decreases. So it was a very complex simulation, and we had computers generate random numbers and do this kind of simulation. It's called Monte Carlo simulation. So it is of practical value, and I think we can have fun during March Madness doing simulating the entire tournament.